This is bubble sort. So for example, we have a list of elements 3, 1, 7, 4, 8, 10, 5, and these numbers are to be sorted in ascending order from the smallest to the highest. So I have a table here with all the sorting that have taken place. So this is how it's happening. So in the first case, let's look at how many elements are here. So we have 7 elements. So that means with the length of 7 elements, we will have 6 comparisons. So in other words, we are going to have a total of 6 passes. That's what it means. Out of the 7 elements, we will have to make 6 comparisons, because each element is going to be compared to its neighbor from the left to the right. So for example, let's look at the first comparison is taking place here, 3 and 1. So 3 is being compared to 1. So, and it is true, 3 is greater than 1. So what's going to happen here is it's going to perform a swap. So a swap is going to be true. So we're going to say true, we need to swap. So at the end of the day, we will have 1, 3, 7, 4, 8. Let me put my true here. So we'll have true, there needs to be a swap. So 1, 3, 7, 4, 8, 10, 15. So this has been swapped, these two values. And then in the second loop, inner loop, we are going to make a comparison between an element which is now second and third. First we did first and second, now is second and third, which is 3 and 7. So 3, okay, so we are going to say 3 greater than 7 is like a question. Is 3 greater than 7? So we put a question mark here, and the answer is false. So it's not true. So then that means we will not swap anything, and then to rewrite that, we just rewrite it as it is. So check 7 and 4, 3 and 7 are still sitting the way they are here. Okay, and then the next thing is we are going to compare element in the third and fourth place. So we are going to say 7 greater than 4, it's a question mark, 7 greater than, and it's true, so since it's true, then we need to switch these guys. So the 4 comes where the 7 was, and the 7 takes the place for 4, and then we are done. So we come to this and make another comparison. Now element in the 4th and 5th place, 7 greater than 7 greater than 8, it's a question mark, it's a question mark. The answer is false. So it's not true, so we'll not make any swap. And then we go to the next one, we make the same comparison here, 8 greater than, so I'm just going to use this, 8 greater than 10. 8 is 8 greater than 10, so I'm just going to create more space. Is 8 greater than 10? answer here is false, so we will not do anything. It's not true, so we rewrite it as it is here. The rest we just copy them. Now we are making the last comparison. Element in the 6th and 7th position are being compared. 10 greater than 5 is a question. The answer is true. So since it's true, we swap them. And then that's the end. It's the last element. So we'll have 10 taking the space of 5, 5 taking the space of 10. And this, we've come to the end of the first loop. And we call this pass 1. We can call this as pass 1. Pass 1 or iteration 1. So we can call it pass 1 or iteration 1. Iteration 1. Then we go to the next iteration. So by the time we are moving to this iteration, the biggest number, which is 10, has bubbled to the last position, the most right, and it's in its correct position. And then we are going to be sorting normal 7 elements but 6, which means we are going to say we are going to make 5 comparisons. So that's why you have 1, 2, 3, 4, 5 arrows here, comparisons. So we'll compare this 1 and 3. Swap? No. Should we swap? 1 is greater than 3, false. No swap. Then we got the next one, 3 and 4. 3 greater than 4, false. No swap. 4 and 7, 4 greater than 7, false. No swap. 7 and 8, this is also false. And 8 and 5, this is true. And then we have come to the end of that first loop. So now we have 2 elements that are sorted so far. It's the 10 and the 8. And we can call this as our second pass. Iteration 2. Iteration 2. And then we just copy that. So 10 and 8 are sitting in their correct position. Now we'll have, instead of 6, we'll have 5 elements. That means we'll make 4 comparisons. 2, 3, 4. So 1 and 3, this is going to be 1 is greater than 3. This is false, so it means no swap. And then we compare 3 and 4, also false, no swap. 4 and 7, that's also false. And then 7 and 5, that's true. 7 is bigger than 5, and then we swap, and we've come to the end of that. Okay, so now here we will have 3 elements that are sorted. It's this one, 7, 8, and 10. And then we got the last one. In my case, I'm calling it last because I know what happened. So I will explain shortly. So this means we are now going to compare 4 elements. So we'll only make 3 comparisons. 1 and 3. 1 is bigger than 3, false, no swap. I'm just going to extend this guy, so I want to work within that space. And 3 and 4, false, no swap. And then 4 and 5, false, no swap. So we've come to the end of that. All the elements have been compared. So that means when you get false running, no swap, in other words, when you get no swap throughout the loop, throughout an iteration or throughout a pass, it means those elements are in order. There's no need for you to continue comparing. So iteration 3, as you can observe, there was no swap. We compared and we got no swap, so that means all the elements are in order. And then since we say there's no swap, then the elements are in order. So now let's go and look at an algorithm in a form of pseudocode that we have. So as you can see, as we move along, the number of green blocks are reducing. In other words, the number of comparisons are reducing. So we had 6 comparisons here, and then we had 5 here, and then by iteration 3 we had only 4, and then iteration 4 we only have 3. That means if we have to keep going, by iteration 5 we'll only have 2, iteration 6 we'll only have 1. So these iterations are reducing as we progress. Okay, now we move to the part of pseudocode. So we have the list of numbers here in an array called nums. So what's happening is we are going to call these numbers as values or elements that are sitting at a position, and these positions are going to call them, we're going to give it a name. We're going to call it J. So J0, J1, 7 is at J2, 4 is J3, J4, J5, and J6. So we are going to do that, and just for illustration purpose, I can do it like this, which is totally fine. I just want to help myself to be able to see this, to see what's going on. 5, 6, 7. So I can clearly see that at J0 I have 3, J1, 2, 3. Sorry. This is 3, 4, and that's 5, 6. So as you can all see, okay, so I have at J0 there's a 3, J1 there's a 1, J2 there's a 7, J3. These are the positions that I have. So now what's going to happen is this. I'm going to say, for just going to create my loop here using this internal loop. For I is equal to, we are going to start from, because you can see it's reducing, so we are starting from, in the first run we have 6, and then in the second one it's reduced to 5 green blocks, and then in the third run it reduced, as you can see, to 4, and then to 3. So it looks like it's coming from the highest value, which is the highest value that I can call here, which is 6, because we have 7 elements, so we're making 6 comparison up to it's supposed to be, each time it's reducing. At first it's going to be 6, and then it will go down up to 0. Okay, up to 0, and we are going to say we are going to be reducing it by 1. Okay, you can call it like that. You can just call it like that, and then we will have another loop which is the inner loop, for j is equals to 1, or let's say 0, up to, from the first element will be compared to the second element, the third, the fourth, and so on. So 0 up to wherever I is, okay, at any position, wherever we are, that's where we are going to stop. And then we will have we are then going to have to check if nums, if the value of nums at position j, at any position called j, let's say 0, is compared and it's found to be bigger than the value which is at the second position j plus 1, then something needs to happen. So we need to keep we need to keep remove this value which is at the position which is the same, because we are swapping the second position. That means like this one, remove it, keep it somewhere, and we're keeping it in temp, and then take the nums, which means take that value which is in the first position, and we will then give it to this one, like that. We'll take that value, give it to this, and then in that space we will receive whatever is in position 1, and now whatever is in the temp must be given to whatever to the space in the first position, and that's it. And then we end our loop here, and our other loop here, and 4. That's it. Simple code. And then we can then print our nums. If you have to print, you can actually have it like this. For I is equals to 1 up to, not 1 but 0 up to 6, and then for j is equals to 0 up to whatever the value of I is going to be at that point. Okay, so we can just print it straight like this, and that's the code. And this one is not even necessary. You can just remove it. And now there's a part where we're saying whether we need to swap or not, or whether we need to keep going with the comparison. Now in this case we said there's no need, so when there's no swap, so swap, we keep giving it a false value. That's a false value. And then if there's a swap, so we'll set swap to true, and then we'll check it here at the end of the first loop. We'll check. Now here is the condition. If swap equals to false, then we need to break out. to break out. Okay, so I think I put it at the wrong place. I need to get it out of here. Outside this if there. So after this I need to come and check if this is really true. Then I need to break out of that and just to come and print. Now I'm going to head to the part where we are going to use Python to quickly check what is happening. So I have my Python text editor here. So I'm using Thorny, very lightweight. So I'm going to copy that, copy this, and then I'm going to paste it here, just so we know what we are dealing with. So these are the values that we have, and then we are going to start looking at ways now to do this. Okay, now we are going to start with a loop for I in range. So that means we'll start from whatever. I is going to start from the highest value, which is the length of our nums, and then but it's always -1 up to 0, and we will be moving in reverse order. That's why we see -1. So every time we'll go backwards, -1. Okay, and then we have another inner loop for j in range, whatever I is at this point, and then we'll start comparing. If nums we start comparing is bigger than nums, j like that. Next one, if this is true, then we need to get this temp variable to give for us this nums, which is at j plus 1, because we are going to place something there, and then nums that j plus 1 will now keep whatever nums j had, and then the nums. Okay, so we have swapped in the second. Whatever was in the first has gone in the second place. Now whatever is in the first place, the space in the first place, will then be given to whatever is in the temp, and that's it. And then after that we can print the nums like so, and this should work with no error. And there we have it. The values are running in that order. Now we were saying we do not want to continue swapping if we realize that the items are already in order, and this is where we now bring in the swap. We set it to false, and then here we say swap, we set it to true, and then we check if swap is set, whatever is set, and if it's false, if this is false, then we want to break, and we want to do this right here. We want to do it here. and then we run this, and there we have it. This one actually stops earlier, does not make unnecessary comparisons. Simple as that. Thank you. That's bubble sort.